Hi. So yesterday uploaded this question like among these three free radical, which one is having which geometry. So let's discuss more about this question. Okay. So now in general we all know that free radical is generally sp2. Generally it's generally free radical sp2. That means what? That means planar. We all know that sp2 means planar, right? Now if I represent it like how will be structured, then it will look like this, right? It's a pure p orbital, and the radical, the single electron, will be situated in this pure p orbital. This is pure p orbital, isn't it? And this bonding electron, they are in sp2 hybridized orbital, correct? These are all sp2 hybridized orbital. So we know that, but this is not the case in every free radical. Now for this trifluoro, when the fluorine is attached with the carbon atom, in this situation, or here it's a cage ring structure, this kind of free radical compound, they can't assume this planar geometry or sp2. They actually take pyramidal shape. Pyramidal means sp3, correct? So this is the main important part, that C is free radical like this. In general, any radical except these two, they always assume planar geometry sp2, but otherwise this two compound they assume pyramidal shape, that is sp3. But if you want a very detailed discussion like why is this difference, then I'll explain. Okay. Now the thing is, here in this when the R is equals to H, suppose it's a CH3 radical. So here it is sp2 hybridized, and this radical free electron, it's in a pure p orbital. Now we all know that between sp2 hybrid orbital, I am representing by HO, and sp3 hybrid orbital. So these sp2 hybridized orbitals are lower in energy, or low in energy compared to sp3. Okay, so it's high in energy, because more the s character, less is energy. More the s character, less is energy, because the s orbital is what is, it just directly attached to the, not attached, it's closer to the nucleus, so it's low in energy. Okay, so now this sp2, it's having what? It's having 33.33% s character, but here it's having 25% s character. So since it's having what? It's having greater s character, that means it's lower in energy. Now when this free radical electron, it is energetically very much favorable to keep this bond pair electron is sp2 hybrid orbital, because it's low in energy compared to sp3. So there is two options. Either you can keep all this free radical and all these three bond pair electron in sp3 hybrid orbital, or you can keep this 3 bond pair electron in sp2 and one is pure p orbital. So that's what energetically very much efficient. That's why it always tries to assume planar character, not sp2 hybridization, that is planar geometry. But that is not achievable in these two cases. Why so? Now see, in CF3 what happens? The thing is, Here the fluorine atom is what? It's more electronegative. There comes a rule, Bain's rule. What rule? Bain's rule. So according to Bain's rule, the more electronegative atom will always favor less electronegative orbital. That is, orbital with less electronegative means what? Less s character, because s character means what? S orbital is closer to the nucleus, very much electronegative, tightly bound, so high electronegativity, right? So more s character, I'm writing in short, that means high electronegativity, En. Now according to Bain's rule, what? It said that more electronegative atom will favor less electronegative atom, the electronegative orbital. Now sp2 and sp3, in between sp2 and sp3, here it's having more s character, means more electronegative, and this is less electronegative. So it will favor, this fluorine will favor what? This sp3 hybridized orbital. And what is the actual reason? This Bain's rule is a conclusive, right? And what is the actual reason behind this Bain's rule? Now you see, if these are kept in sp2 hybridized orbital, which are more electronegative, so it will try to, here is bond pair electron, right? So if it's an sp2 hybridized orbital, they will try to withdraw the electron towards itself. The hybrid orbital will try to keep the electron towards itself. And here is fluorine, it is also highly electronegative. It will also try to keep the electron towards itself. So there will be a clash. The hybrid orbital is also electronegative, and here fluorine is also electronegative. So there is a clash. So we have to keep the hybrid orbital less electronegative so that there will not be any clash. That's why when there is this electronegative atom is attached to carbon, it tries to be in a less electronegative orbital. That's why it prefers what? It prefers sp3 hybrid orbital. And in sp3 what? There will be 4 orbital, 1s and 3p, means they hybridize and they form a 4 sp3 orbital, right? One is here, another is here, another is here, another is what? Another is in here, like this. And the free radical will be in sp3 hybrid orbital. I hope it's clear. Okay. So this is the reason why this CF3 radical assumes this pyramidal shape. It's pyramidal shape. Now what happens in this this is called adamantane. This is called adamantane. Adamantane. The free radical is in here. And here is what the case. Now you see, it's a cage structure, right? So these 3 bonds are like this. These 3 bonds are like this. It's very difficult to show. These 3 bonds are like this. Okay. They can't assume the planarity which is needed. They can't be in a one plane like this. They are actually like this. All three are like this. Okay, I am not being able to show that by one hand only, but they can't assume the planarity because of this strain, because of this high strain. Okay, so if they assume planarity, it will be like this, which is not possible here. So there is what? Huge strain. That's the reason it prefers to be in a pyramidal shape. So the here this radical is in sp3 hybridized orbital, so that it assumes the pyramidal shape. So that's the lecture all about. So here is the summary, that in general free radical tries to assume planar geometry, that is sp2 hybridization. But here in case of trifluoromethyl radical or adamantyl free radical, any bicyclic H compound, cyclic H compound actually, they always prefer to be in a pyramidal shape. They always try to assume this sp3 hybridization because of these two reasons. So here we got to know what about Bain's rule, we got the idea, and what is the basic of this Bain's rule, we also got the idea, and about this adamantine also. So if you have any doubt, please let me know, I'll try to explain. Okay, thank you, bye bye.